And so, when we continue on here, so if the next one's congruent. So we can look at the markings on the triangles. We've got these two sides are congruent by their markings. We also have these two sides are congruent. And even though it's not marked, we know that their third sides are congruent because it's the same segment. So if they have a shared side, you often have congruent triangles, and you have that we know that anything is congruent to itself. So I would say, yes, these two triangles are congruent by side, side, side postulate. We know that triangle X, Y, W is congruent to triangle. Now here's where we have to get careful. It doesn't matter how we name the first triangle, but we have to figure out which one is congruent to X. And it's trickier when you know the sides. But if I look at my markings, colors are wonderful. X is between the red and the blue side. So between the red and the blue side is Z. Then my next one was Y. That's between blue and green. And the other triangle between blue and green is W. And then in the first triangle, angle W right here between red and green is angle Y. And sometimes it even helps just go through and mark them, somehow mark them the same. Put a little star in that one, a little dot in that one, whatever consistent mark you can put. Okay. So, the postulate, they answer all the questions, side, 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 and tell me which two triangles are congruent. There's some more pictures here to look at. Same question, are they congruent? So, we have two pairs of sides marked here. So, I'll go ahead and make these blue. I'll go ahead and make these red. And then what we have is we have vertical angles that we know are congruent. Those two angles must be congruent because they are vertical angles, and that was a postulate that we looked at before. So I'm seeing red, green, blue there. I'm seeing side, angle, side tells me that triangle, if I say ABC, so angle A, here's the red side and the unmarked side. So that's going to have to be E. Then angle B is the blue side and the unmarked side. So that would be angle B. And then angle C is in this one triangle is congruent to the angle C in the other triangle. It's two different angle C's, but they're vertical angles, so they're congruent. Now it gets harder to see, harder for us to wrap our heads around when we have overlapping triangles. Okay, so the statement over here tells us that JK is congruent to NM. That one's not too hard to see. We also know that KN and MJ are congruent. So KN and MJ are congruent. And again, we do have a shared side. I'm going to use blue. Both triangles have this. Now we're looking at the overlapping triangles. Let's see if it lets me do this. Oops, I wanted the highlighter. I'm looking at this this whole triangle, okay, compared to this whole triangle. So there's overlapping stuff there. So in terms of doing that, we have to be careful when we name it. It's going to be triangle JKN. So J down here is going to be N down here. K is up here between red and green, so M is up here between red and green. And then N down there is going to be J down here. And then that's by, and this was a little harder to see, it was by side, 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 because that was what we were told first was those three pairs of sides. Let's see. so then we move into proofs involving congruent triangles. And they always seem to be the thing that we just don't like to do. Just don't panic over proofs. We'll just take our time and go through them. It's really just about making a valid decision based on what we already know. Okay, so this particular proof here, we're just going to do two common proofs. So we have some given information. So remember, that's our starting point we talked about in chapter 1. Segment BE and segment CE are congruent. So that's the first piece of information they tell us. They also tell us that segment AE is congruent to segment DE. So the red ones are congruent and the blue ones are congruent. And they're asking us to prove that the two triangles are congruent. So when you do a two-column proof, what we do is we start with exactly what they just said, two columns. One column for statements and one column for reasons. So basically, we'll always start off with the given information. Segment BE is congruent to segment CE. And you can put it all in one. You don't have to. You can separate it. Usually just throw it all in the first one. And why do we know that? Because that's what they told us. That's what we're given. Okay? So keep in mind all the things we just talked about on ways to prove triangles congruent. We either have to have side, 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 angle, or angle, side, angle. So go back and look at your picture. Label those diagrams. Without labeling the diagrams, I don't know how anybody does these proofs, okay? Well, I can look at this, and I know also, besides, so already in my proof, I've got two pairs of sides congruent. So I've got the red and I've got the blue. But I also have vertical angles. Vertical angles is something you can get off of a diagram. Okay, so my second statement can be that angle 1 is congruent to angle 2. And my reason for that is because they are vertical angles. Vertical angles are congruent. And we can abbreviate as long as the point is made clearly. Now look at my picture. If I was doing this like one of these up here, are they congruent and why? I would know that because what do I have marked? Red is a side and blue is a side and green happens to be the included angle for those two sides. So I actually have, in my picture, I can see side, angle, side postulate. Okay, so and it matches up with my statement, triangle AEB is congruent to triangle DEC. Yeah, maybe you're trying to build something. You've got two pieces of lumber, or 4 pieces of lumber, 2 that match each other, 2 sets. As long as you make that angle in between the same size, you're going to have congruent triangles. It's just using these now, this piece of information to set that. Okay, so sometimes we have just a little more work to do with this. So we've got that word bisects. Remember, bisects means cuts exactly in half. So if it cuts it in half, that means there's going to be 2 equal pieces. So just kind of think about that when you see that word. So it's telling us that ray ZY bisects angle WZX. So the yellow thing cuts the red thing in half. Now if you're cutting an angle in half, you're going to get 2 congruent angles. Okay? So just keep in mind that's what's going on in the first statement. I'm going to go ahead and erase those marks because it's not telling us those things are congruent, but to get an idea of what we were, looking at our information. Now the stuff I can mark, WZ is the same size as XZ. Well, those two are the same length, whichever way you want to mark that. And angle W is congruent to angle X. Okay? Now, when we set up our proof on this one for our statements and our reasons, so our statements and our reasons, okay, see that first statement, this line segment, it's not writing, there we go, line segment ZY bisects angle WZX. I'm just going to put that one piece of information in there because I'm going to make a direct conclusion from that. Because, what I marked before, because that ray bisects that angle, the two equal pieces that we're cutting an angle in half, the two equal pieces in this case are going to be an angle. We cut a segment in half, you get two smaller segments that are the same size. Cut an angle in half, you get two smaller angles that are the same size. So since ray ZY cuts angle WZX in half, the two that I just marked are the same size. So how do I name this angle? Okay, it's going to be angle WZY is congruent to angle XZY. And my reason what you'll probably see in most textbooks, I guess, would be definition of an angle bisector. Okay. Sometimes with my high school kids, I make them write, a bisector divides an angle into two congruent angles. To make sure they're really thinking about what's happening. We cut an angle in half, that's going to give us two congruent angles. Okay, now I don't have the other given information. I don't have this in my proof yet. So I do need to put that in there. I need to put WZ, what's up with my pen today, is congruent to segment XZ. It's not writing. And angle W is congruent to angle X. And that's also just given information. That's all part of the given information. But now look at my picture and think about the postulates we talked about. I can see, marked in my diagram, I can see angle, side, angle. I've got the blue angles, the red sides, the green angles. And it matches up to this statement. That's how you know you're done. Okay, WZY is congruent to angle, triangle XZY. Okay, so we really just had to make one conclusion. That bisector gave us two congruent angles. And then with the other given information, we had angle, side, angle. That's really all we need to do. And we got one more here. Next one. We've got some overlapping triangles. Might have to go quickly through this one before I run out of time. Statements, reasons. Not writing. My statements. It is not writing. I'm going to just go over here. I've got my given information. And my congruent sign. There we go. FG. Angle EHG congruent to angle FGH. Marker diagram. EH is congruent to FG. Angle EHG. So that's this whole angle. It's the whole thing down here to FGH, which is this whole angle down here. Okay. And we're trying to prove triangle EGH. Now notice that this whole triangle is like the one example before, and then the other whole of the overlapping triangles. Alright, so here's our given. We've got that marked. Well, guess what? They have a shared side. So what we say is we say HG is congruent to HG, and our reason is reflexive property. Reflexive property is the one that just said that everything is equal to itself. And now we should be able to see in our picture that we have, we've got those sides, we've got